holy guacamole, we have reached episode 9 of Let's Talk About Electric Vehicles. This is also the third part of our series about supercapacitors. I welcome you. My name is Teresa, I'm an economist, and in this podcast I disclose mysteries and conspiracies about the electrification of the transport sector. I am an academic researcher and I only refer to unbiased, as unbiased as possible, research-based sources. This is a sales-free environment. My motivation only roots in genuine interest and passion for innovation and technology. And so far, in the first and the second part of the series, we have learned about what a supercapacitor is, how it has shaped several sectors in the economy already. And today, we will finally focus solely on how or if supercapacitors can turn the automotive industry upside down. It really makes sense to listen to the first 2 episodes first because I build on that knowledge. But with that being said, let's get started. A million cycle life. This is what supercaps promise. Take that, lithium-ion battery. There's no way a commercial battery with usable 1,000 charging cycles can keep up with that. A longer lifespan means less battery disposal, so a benefit for Mother Nature and for our bank accounts, as you don't have to replace the battery that often. If that didn't convince you yet, let's head on to safety, because the right version, the right type of supercaps can be non-toxic, non-flammable, there's no risk of thermal runaway, and can be discharged to 0 volts in less than a second in case of an emergency. It even becomes a fire extinguisher. What? And as opposed to the lithium-ion batteries, the fast charging and discharging does not even harm the supercapacitor. So there's no or almost no degradation in capacity or efficiency. An interesting fact. Interesting fact. There is 3 types of supercapacitors depending on the electrode materials. Which one to choose depends on the requirements of the specific application. Symmetric supercaps use the same materials on both sides. They are cheaper, they last longer, and they are quite high in power, but they are low in energy density and hence they are low in energy capacity. For higher capacity requirements, the asymmetric supercaps suit better. They use different materials for the electrodes on each side. On the downside, they are expensive and also they have a shorter lifetime. They lose 20% of their performance after 1,000 cycles. And there's a third type, the so-called hybrid supercapacitors. They are not so common yet, but there's a lot of research going on about finding the right material. One research project that I investigated, they even included egg white as a possible material. This is so fascinating. Back to reality. Oh, there goes crack. Okay, let's go back to reality after this very optimistic intro. Supercapacitors cannot replace batteries. Given their natural features, they have a very limited energy storage capacity and they even start leaking energy after some time. So when you connect it to an electronic device or an application, it shoots all of the stored energy out in a very quick and powerful manner, and then it is empty. And furthermore, they also have a very low voltage. The latter you can kind of overcome by putting the cells in series to sustain a higher voltage at the expense of stability though. However, this too fast charging and discharging has probably been the major challenge. Therefore, it really makes sense to combine it with another energy storage system such as a battery or hydrogen. Especially batteries could benefit from this kind of combination because the supercapacitor is a perfect complement for the battery's weaknesses. Delegating the sharp and powerful charge and discharge situations to the supercap reduces the stress for the battery and therefore increases its lifetime. But such a combination also, on the other hand, needs a smart management and control system that monitors when and how exactly the energy flows between the motor, the supercap, and the battery. So the interesting question now is whether or not installing the supercap is worth all of the effort. So the question that comes to my mind is, how often does a battery really have to deal with short and powerful charge and discharge situations in an electric vehicle? Automotive manufacturers have two particular situations in mind where the supercap could come in quite handy, which is acceleration and regenerative braking. Let's start with acceleration. If you want to live your speedy racing driving style with a lithium-ion battery electric vehicle, that can cost you very valuable capacity and therefore it costs you driving range. So how frustrating that must be. Now you finally got your electric motor, which has by default a stronger acceleration than any internal combustion engine. But if you make use of it and if you push the pedal down and speed fast, then you also damage your battery. Since the supercapacitor can dump energy into the motor quickly, it could make it possible to keep this sporty driving style without the expense of driving range. As for regenerative braking, if you don't know, this term refers to the ability to generate energy back from the deacceleration process, especially useful in urban stop-and-go traffic, I guess. This is quite controversial since these short charge and discharge actions harm the battery, but here's where the shining moment of the supercapacitor could be, because it could collect the energy from the braking situations and keep it for the next harsh acceleration. This mechanism is not a new invention. It has been commonly used in the industrial sector for years, as you probably know from my last episode, but today I introduce you to some fascinating examples where it has already successfully been implemented in the public transport sector. Trains, buses, streetcars, you name it, the supercapacitor improves it. And so it already does in Cologne since 2001 and in Madrid since 2003, where Siemens installed trackside storage systems using Maxwell's supercapacitors. Similarly, in southeastern Pennsylvania, where trains stop and accelerate several thousand times per day with a duration of only 15 to 20 seconds. Therefore, the Pennsylvanians installed a combination of supercapacitor and battery that employs exactly the mechanism that I've explained before, and therefore it allows to assist the acceleration process by this excess braking energy, and this results in a 10 to 20% reduction in electricity consumption according to their reports. And as if all of this was not fascinating enough, there is even another way of how to make use of the supercapacitor. I found a research paper that suggests charging stations at every bus stop, and then the bus can charge the energy required just to make it to the next bus stop. And since the supercapacitor makes it possible to charge within less than a second, the bus would not even need a battery. And remember that the supercapacitor lasts almost forever. So high efficiency, low cost, low disposal, good for the government's bank account, I guess, and good for the environment. Such buses already exist in Shanghai. They are called CAPA buses, C-A-P-A, and they are equipped with two roof-mounted pantographs for flash charging the supercapacitor at every single bus stop. This is so ingenious. I hope that you see now how important the niche market of urban buses could be for the development of supercapacitors. Coming on to passenger cars. The supercapacitor is useful in combination with electric motors and internal combustion engines alike. Mazda, for example, uses the supercapacitor already for regenerative braking, and they claim on their website fuel savings of 10%. It is also common to use a supercapacitor instead of a regular battery in diesel and gasoline cars for the starting process. And furthermore, Toyota already uses the supercapacitor in their hybrid vehicles. The prospects of supercapacitors in the full electric vehicles, they lie in the combination with a lithium-ion battery to reduce the stress of the battery. I found plenty of studies suggesting such a combination, but also the combination with a hydrogen fuel cell technology is very reasonable as it reduces the fuel consumption. The main focus of all of the current research seems to lie in the development of a sustainable management and control system. My dear visionaries and those who want to become visionaries, it is time for innovative visioning. Give your beautiful scientific fact-based brains a break and turn on the creative part in your brain. With all of the knowledge about supercapacitor that I just presented to you in this 3-part series, what do you think will be its role in the automotive industry? We know that supercapacitors cannot replace lithium-ion batteries. Their potential rather lies in the combination with batteries, to help out in those situations where the battery's performance is not sufficient. So hence the potential lies in combining the advantages of both energy storage technologies. Batteries, they suffer from fast charging and discharging. Supercapacitors could assist for fast acceleration by collecting the energy from the regenerative braking. When a battery has less stress, that makes it last longer, so that decreases the need for a larger battery pack, that decreases the cost, that decreases the environmental impact, and so on and so on and so on. We have reached the end of this episode. I really hope that I could teach you something new today. You will find all of my references and contact information in the show notes. Please don't hesitate to reach out to me for feedback or topic suggestions or remarks, or if you just want to talk, I don't know, if you just want to talk about electric vehicles. And by the way, by the time that you listen to this podcast episode, I will probably already have moved to Edmonton in Alberta. I'm very excited. So if you're from Edmonton, please, you have to reach out to me and we have to talk about electric vehicles, because I don't know a single soul in Edmonton. Okay, no, that's not true. But I don't know any electric vehicle freaks like me in Edmonton. So please don't hesitate to reach out to me. And we will talk about electric vehicles again next week. Have a wonderful day and bye!